Question 6 has quite a lot to read through here, and quite annoyingly this bit of information here we don't actually need till part B. It's this piece of information here that we need for part A. So if I'm going through part A, I'm going to go for the vertical height of this, and it initially is going up here the opposite bit over there, so that is 12 sine alpha. We don't know what V is, I'm not caring about that. A is minus 9.8 as usual. S, from this piece of information, it's 4 meters above A when the time is 1.5 seconds. And so with this information, I can now figure out what the alpha is going to be. The formula I'm going to use here then will be just a usual S equals ut plus half at squared. I'm going to put in the S value here as 4. I've got 12 sine alpha times by 1.5 here. And then I've got plus a half minus 9.8 times 1.5 squared. Now, just rearranging that, I'm going to add this to both sides, so I'm going to get 4 plus all of that, and then I'm going to divide by the 12 times 1.5, so dividing by 18 there. I'm going to find out what the sine alpha is equal to, and tapping that into the calculator gives you that sine alpha is equal to 0.8347, and if you inverse sine that, you get 56.6 degrees. So now on to part B. And part B, we actually are interested in now when it hits the ground here. We know when it hits the ground here that it's going at 15 meters per second, but that is this direction here. What we want to know is what sort of angle it goes to. So to do that, what I'm going to think about is that horizontally this is when it hits the ground. This is V is just equal to 12 sine alpha, so 12 cos alpha. This speed, it's set off at 12 cos alpha, and of course it keeps going at 12 cos alpha. So along the bottom here, we know we're going at 12 the cos of 56.6. We've also been told that it's hitting the ground here at a speed of 15. And so I'm going to try and do a little right-angled triangle here. I'm going to use this as theta here, and what am I going to do? I'm going to do an inverse cos of 12 cos 56.6 divided by 15. And when you do the inverse cos of that, you get 63.86 or 63.9 degrees. Sorry about that little mistake there. Say it's a cos. You're going at 12 cos alpha all the way along, and then I'm doing this right angled triangle here to find the angle it hits there.